Hey, so in this video, what I want to try and do is help set up the developer workflow and everything, right? So this is the actual TankTourney game. Uh, it's a Unity. It's made in Unity, so this version control is actually secondary to whatever Unity is using. So I haven't actually cloned this down and see if any of this works, but I have created a couple of releases for that are completely built for the three platforms. So we'll just go ahead and download one of these. And while that's downloading, we will go ahead and grab the Python client. So this is how we're going to be programming our bots, or one of the ways. Right now, we're just using a JSON over a socket, but if that changes, it should be seamless for us to change. So the code should be independent of how the communication works. That's why I try to write the clients myself. So this shouldn't take too long. And we'll try and run the game itself. So Max would have the security problem. So once you try to run it for the first time, you can go over to your system preferences, securities, and they have this little bit that pops up. So we can just say open anyway, and then try to run it again. While that's running, we'll go over to our newly cloned Python client and set that up. So pip install our new library. Perfect. Now, there's two modes to the game. The normal mode is how the tournament or any competitions should be run. The debug is going to help us with the development workflow, just to check whether or not our algorithms are accurate or to what degree they're accurate. They'll have a lot of information, but because we're using an unoptimized communication over the socket, we can't really send all the information, so the obstacles are only local. So I'll show you that in a second here. So once we get started, the network starts right after that round one text goes away, and we can just try our random script. So this is going to be just trying to do random actions, right? So every once in a while it kills itself, and that's about it, right? So you know the game's connecting to the Python client and everything. And if we go ahead, actually we'll look at the code right after here. We'll try the second example of mapping map, and we have our map with our debug information. So this isn't, this isn't done through any algorithms. This is just the game telling us exactly where we are, what our direction is, and where all the obstacles direction is. And we can play around with this by moving in the game itself using the arrow keys, WASD for the blue guy, and so the map actually just starts creating itself, right? There is some overlap. I haven't worked out the glitches there, but you get a general idea of what the map should look like, and you compare that to what the map, the created map from your SLAM algorithms and such. You can also run a second client here to see the opposite player's side view, right? And that's about it, right? I'll be trying to work on the camera information as well as the next iteration. And I guess that's about it. That's the main parts of it. Oh, and I guess after the camera, I'll try and make a ROS node, but you shouldn't wait for that, I guess, right? That's might take a while. So we'll go over the code a little bit to see how everything is architected. All right, let's open this up. So in examples, random. So we create an instance of the tank itself. if you ever wanted just to run a function using the inputs or outputs of a what's given from the game, you can just write a function and use the lambda part and pass that function into it, and it'll create an object that works with this tank, right? So you add that part in, you say these are the outputs that it's going to be providing, and you have three numbers there, three outputs, three strings representing what those outputs are. And then this is later used right here in the control part, right? The control, well, I guess we'll go in order here. The observation is going to be what the tank game is actually giving you. So you'll see that these outputs are not there unless you're debugging and developing. So you can't depend on these in your algorithms, right? So you're only going to be using the distance of the flag, a whole array of LiDAR distances, the amount of distance traveled from your last observation, angle turned from your last observation, and whether or not the game is paused. This is also threaded, so this runs in parallel or concurrently with all your other stuff. This is just to show you that you can also write arbitrary functions to do whatever you want with your information, so you can record it and then play it back if you want. And lastly, the part that actually sends the information, sends the numbers you want over to the server itself, right? So it's fairly straightforward, and this just runs in a loop, right? This function runs, then whatever the observation needs to do, it runs, and lastly, the control part runs. In terms of the programming, that's relatively it, right? So you can just write another part. So we'll go over creating a new part. So I'll just make this loads. Try writing a new script. On to activate video. That's where we pip installed it. Testing. Open that in our editor. We'll copy this over. It's good enough. This is doc-ops. Not necessary. So what we care about is we're going to try and change this, right? So we have a whole bunch of observations, and we can delete this. This is just debug stuff. We can pretty print our information that we're actually getting, and we'll pretty print our flag information and distance traveled and angle turned, right? So this is a generic function, so I'll actually show you how this works. Let's call it my pretty print, and the three arguments you're passed here is going to be passed into your function that's going to be you're creating, right? Oops, so let's do that. So flag, dt, and at, and then we can just say flag, or and dt, at, right? So we don't have, let's say we don't want to control it. We're not going to have any actions, and we won't need this as either, right? So we'll put these together actually. So the order doesn't really matter because it's just going to keep looping over and over again. But just for organizational sakes. Oops. All right. So this is just going to read in our observations, then print it out, and that's it. So let's see what that looks like. And it's going to need 1. The game needs to start. Also, we have like 300 seconds on the clock. We have none. We're not reading anything. Looks like it's not even connected. Seems like. Alright, let's see if this was the cause. We'll just give it a random movement and see if that lets it connect. Okay. So it seems like you need to connect your controller in order to even see anything. Right? So that's something I learned too while doing this. We'll just make it 0 so that we don't have it making any of the, oh, it needs to be a float. Oops. All right, so 39 units away from there. Let's see if I can go closer. 42. There we are. So you can see the 30, 26, the bottom, oops. As we get closer to the flag. So it's an absolute distance. We're going to have to figure out in the code itself how you're going to use that absolute distance to figure out where the flag is, right? But yeah, that's about it, right? So you can play around with whatever information in your functions themselves. If you want state, you can do the exact same thing by creating a class, my printer. So we're just going to print out some stuff. So you can have your init functions there, but the only thing that we care about here is, I'll show you the actual code itself of how these parts are written. So let's take a look at display, right? So we have the display part, and we have an update for the whatever arguments it takes in, and that's it. And that's all that's required. So all of this extra part is just to actually make that image, right? So we're just going to copy this. You didn't actually need to, but these arguments. And we'll have the same print function, right? So this is just to show you that you don't need to use a lambda part right here. It just makes it so that it creates a class and it sets its own update as the function that you're sending in, right? It's a helper. But if you had some state that you want to keep track of, that's how you would do it. All right, so this should work the exact same way as what we had previously. Hopefully, nothing goes wrong, and yeah, so that's it, right? The angle turned, it only shows incrementally, right? So it just shows a little bit. So yeah, you have to accumulate what it is, right? And that's actually Unity units if you're curious, right? So I didn't do any conversions or anything. Everything that's measured within Unity is what you get. And that should cover about everything. If you have any questions, email me, create an issue. If you have any features or bugs you want me to fix, I'll try and get to them as soon as possible. Quick shout out to Jeremy Lau. His LinkedIn is going to be in the description as well. He helped me create the Unity game itself. And yeah, that should cover about everything. Thank you.